Which metal offers higher resistance to the passage of electricity than copper? Aluminium. Even iron will offer more resistivity than copper, more resistance than copper. A wire of 10 ohm is bent to form a closed circuit. What is the effective resistance between the 2 points at the end of any diameter of this circle? So here we had a wire, and this wire AB was of 10 ohms. It's now turned into a closed circle. That's what they're saying here. So here it's made into a closed circle, and they said what is the effective resistance between the ends of the diameter. So let's draw the diameter. So here's the diameter. This is, say, P and Q. So this 10 ohms is divided into two parts. Here we'll have 5 ohms and this side is 5 ohms. We need to find the resistance, effective resistance across PQ. This diagram can be now drawn in the same fashion. Here I have PQ, this is my P and this is Q, and there is, I know, 5 ohms here, they're in parallel, and there is 5 ohms on this side. Now I need to find my resistance in parallel. Formula: 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R, 1 by 5 plus 1 by 5. So 1 by R is 2 by 5 ohms. So R equal to 5 by 2 ohms, which is equal to 2.5 ohms. What is the unit of charge? Is coulomb. Should write as C. Compute the heat generated while transferring 96,000 coulomb of charge, so it is Q, in 1 hour. So time here is 1 hour through a potential difference of 50. So voltage is 50. Peak heat produced means we need to find the energy or the heat, or H. Now here the question is we need to find the heat. The charge is 9600 coulombs. The time is 1 hour and the potential difference is 50 volts. The work done or energy is given as V into Q. So we know our V is 50 and the Q is 96,000. So here I think I have to put another 0 here. And the answer will be 48345, and this is energy, so this will be in joules or work in joules. When a 12-volt battery, so voltage 12 volt, is connected to an unknown resistor, resistance unknown, there is a current of 2.5 milliamperes. Current 2.5 milliamperes. Find the resistance. We need to find the resistance. First, the milliamperes had to be converted into amperes, which means you have to divide by 1000 to convert into amperes. Then we use the formula Ohm's law. In Ohm's law, we have V equal to IR, and the V is 12. The I is 2.5 over 1000. R we don't know. So we have 12 over 1000 over 2.5 equal to R. So the R here will be 12 into 1000. I put 10 here to remove this decimal. This was 2.5. To remove decimal, I put the 10, and that's your answer. The unit will be ohms. 2 lamps rated 100 watts and 220 volts and 60 watts and 220 volts are connected in parallel to an electrical main supply. What current is drawn from the line if the supply is 220 volts? So here is our first bulb. For the first bulb, the power is 100 watt and the voltage is 220 volts. So we can do P equal to VI and find the current flowing there. So it will be 100 equal to 220 into I, and 100 over 220 equal to I. So your I here will be 10 over 22. So the current flowing in this arm, we will put it as I1, and that current is equal to 10 over 22 amperes. Now for bulb 2, here we have bulb 2, and in this bulb again we have power equal to 60 watts and we have the voltage 220 volts. So power equal to V into I, 60 watts, 220 volts into current I. So the current I will be 60 over 220, and the current I, which is I2 now, will be 6 over 22. So here we have I2, which will be 6 over 22. Now this main current I flowing to the circuit will definitely be I1 plus I2, because at this point the I will split into two. There will be I1 flowing in this circuit branch and I2 flowing in this branch, and when they get together again, here will be your I1 and this will be I2. They will get together here at this point and you will get your I. So I equal to I1 plus I2, and your I here is 10 over 22 and this is 6 over 22. So this will be 16 over 22 will be your I, amperes. You can then reduce it. An electric heater of resistance 8 ohms, so let's put there resistance 8 ohms, draws 15 ampere current. So current 15 ampere from the mains for 2 hours. So time 2 hours. Calculate the rate at which the heat is developed. Now the rate at which the heat is developed is power. So basically we have to find the power. Now the formula for power, we have many formulas for power. VI, power equal to I square R, power equal to V square over R. Now which formula are we going to use? Since R and I are given, we are going to use this formula. We have R and I are given to us. So power equal to I square, I is 15 and R is 8. So power equal to 1800 watts. We don't need the time here because just power is asked. An electric iron has a rating of 750 watts. So power 750 watts, 220 volts, voltage 220 volts. Calculate the current passing through it. Current means I. So we use the formula P equal to V into I. 750 is power, V is 220, your I we don't know. So I equal to 750 over 220, 75 over 22 amperes is current. Next is its resistance. So we need to find the R. So again we will use the formula P equal to V square over R. Since we know the V, so power 750, your V was 220, so 220 square, the R you need to find. So the R will be 220 square over 750. So R equal to 220 into 220 over 750. And the resistance here comes 64.53 bar ohms. A torch is rated 2.5 volts. So voltage 2.5 volts. and 250 milliamperes. So current 750 milliamperes. Calculate its power. So first, quite easy, power is V into I, which is 2.5. Now the 750 is in milliamperes, so you got to make it into amperes. Divide by 1000 amperes. So this becomes 750 over 1000. So power is 25 over 10. Over 10 is to remove the decimal, and 750 over 1000. And I think the power here, when you do this calculation, 1.875 watts. Next part, we need to find resistance. Resistance means R. So we know that voltage equal to 2.5 volts and the current equal to 750 over 1000 amperes. And we do Ohm's law. Ohm's law, V equal to I, R. V is 2.5, the I is 750 over 1000 into R. R we need to find out. So we have 2.5 into 1000 over 750 equal to R. Now to remove the decimal, we do 25 over 10, and this is 1000 over 750 equal to R. So when you calculate this, you get 3.33 ohms. The last part, energy consumed in 4 hours, that is the third. So for the time is 4 hours, and we know the V is 2.5 volts. We have current is 750 over 1000 amperes, and the energy consumed here, we can do power into time. We know the power is VI, because that's what's given to us, and the time here is the T. So let's put the values. Your V is 2.5, current 750 over 1000. Now time is given 4 hours, but we cannot work in 4 hours. We have to do in seconds. 4 into 60 into 60. Now the time is 4, and I need to convert into seconds, so 60 into 60. So the energy will be 25 over here 10. I'll cancel this 0, so 75 over 10, and this will be 4 into 6 into 6 into 100. So these two zeros also will cancel. So the energy is 25 into 75 into 36 into 4. So it will be 27123 joules. 2 electric lamps of 100 watt and 25 watt are connected to a 200 volt. Calculate the current flowing through the circuit. So our first lamp is of 100 watt connected to 200 volt, that is lamp 1, and the second lamp is of 25 watt connected again to 200 volt. We have to find the current. So for the first lamp, power 100 watt, voltage 200 volt. So current P equal to VI, 100, 200 into 1 I, so I equal to 100 over 200. So 1 by 2 amperes is the current flowing in one branch. So in this branch, the current flowing I1 is equal to 1 by 2 amperes. Now for the second branch, or the second bulb, we have power 25 watt, voltage 200 volt. So power equal to V into I, 25 equal to 200 into I. So we have 25 over 200 equal to I. So 1 by 4 amperes is the current flowing in I2. So in this arm a current I2 is flowing, and that will be 1 by 4 amperes. So the total current I here will be I1 by I2, because at this point the current splits into two parts. So the total current I equal to I1 plus I2, which is 1 by 2 plus 1 by 4. 4 LCM, so that will be 2 plus 1, so it will be 3 by 4 amperes will be total current in the circuit. The resistance of an electric filament is 230 ohms. So resistance are 230 ohms. The lamp is switched on while the line voltage is 115. So voltage 115 volts. What is the current? What is I? So here quite a direct sum. Ohm's law. V equal to IR, and you need to put your values. 115 equal to I, we don't know, and the R is 230. So the current flowing will be 115 over 230. That is 1 by 2 amperes is the current flowing.